Now that you've learned how to represent the domain and range of a continuous function, let's look at presenting reasonable domain and range. So we have a situation where Jane has 3 cereal bars in her backpack, and each bar contains 130 calories. And so we want to represent the reasonable domain and range for this situation. So the first thing you have to do is, this isn't a graph, so you can't just look at it and go, ooh, that's a continuous line, or that's discrete data points. So we have to think about the situation. Now, one of the tests for discrete data is to say, well, you can count them. Well, I can count the number of bars. However, the test for continuous says that in between your counting points, in between your data points, do all those solutions in between make sense? So yes, we could say at 0 bars, 0 calorie, at 1 bar, 130 calories. What if she just eats 3 nibbles off of that bar? Every nibble she takes on that bar is more calories consumed. So in between 0 and 1 bar, every one of those data points makes sense in between. So this is a continuous. So go ahead and pause your video and complete number 11 and then check back for the answer. So once we've decided that it is continuous, we need to think about our x value, the number of bars eaten. And she can eat anywhere between 0 bars and all 3 of her bars. Anywhere in between 0 and 3 represents our domain, including she can eat 0 and she can eat the full 3. For the calories consumed, same thing. If she eats 0 bars, she's consuming 0 calories. If she eats all 3 bars, she's consuming 390 calories, and it can be any number of calories in between those two numbers, including the bottom and the top. Okay, so number 12 through 15, I want you to pause your video to do all 4 of these at one time, paying attention to the bottom and the top and the left and the right, making sure you're not getting fooled by just looking at endpoints, but go ahead and look at the very bottom and top of graphs, and remembering how to write domain and range for discrete data. When you've completed it, check back. Okay, on number 12, the range was the more difficult one, just making sure you started at the very bottom of the function and went all the way to the very top of the function, which happened on this one to be the top endpoint. On number 13, you got a little bit of practice with infinity and rewrite them as just less than a number or greater than a number. Number 14, it's probably the most difficult, making sure you got your inequality symbols correct. It can be a little bit challenging if you don't write it on the X and Y axis the way we've been doing. And then number 15, just remembering it is discrete because it's disconnected points, and making a table of all the points before writing your domain and range in brackets. Okay, on number 16, we're now going to start looking at situations, determining if they're discrete or continuous, and then writing out the domain and the range. So go ahead, and what I want you to do is read number 16 completely, answer all the questions, pause your video while you're doing this, and then check back for the answers. Okay, this one is discrete because the pool tables are only rented for complete hours, so there's no charges in between the hours. Okay, on number 17, again, I want you to consider if it's discrete or continuous and explain your answer as to how come, and complete all the information, then check back for your answer. The tricky part on number 17 is just realizing that if they raise $0, they're still donating $250. And then for everything they raise more than that, they'll be donating half of it. So it's really everything in the domain 0 and greater, and everything for the range is 250 and greater.